In this last video, I'm going to speak with you about something called post-hoc tests. Post-hoc tests are critically important when you have a significant ANOVA. We're going to talk about the logic of post-hoc tests. We're going to talk about two different types of post-hoc tests, Scheffé and Tukey HSD. You're not actually going to calculate these tests, but you're going to learn what they are used for. And finally, we're going to apply our learning at the end of this video. So how do you know which treatment is different and which treatment is not different? We just don't have all the information when we have an F test. We don't. ANOVA only indicates whether there's a statistically significant result, but it doesn't say where the comparison is significant. For that, we need these what are called post-hoc tests. So let's just take an example. We have an F with degrees of freedom 2 and 27 equals 8.93. Our F score indicates a significant mean difference, but we don't know which ones and we don't know where. Treatment 1, the mean was 3. Treatment 2, the mean was 5. Treatment 3, the mean is 10. We don't know which groups are significantly different. Post hoc tests are additional tests completed after an ANOVA to determine exactly which means are different and which ones are not. So post hoc tests are only completed after a statistically significant F score. If we do an ANOVA and our F score is not statistically significant, we move on. We don't do these post hoc tests. So there are two types of post tests that we're going to be talking about. There are many different types of post hoc tests, but the ones we're going to talk about are Tukey's HSD and the Scheffé test. It's a French word, Scheffé. All right, honestly significant difference. This is Tukey's test. So Tukey's is a procedure that computes a single value, and what it does is it determines the minimum difference that is necessary for significance. It's used to compare any two treatments or conditions, but one limitation of Tukey's is that the sample sizes have to be the same for each condition. So we don't always have sample sizes that are the same. And so sometimes we use the Scheffé test. And the Scheffé test is an extremely cautious method for reducing type 1 error. It's considered the most conservative and one of the safest tests. It evaluates differences between two treatment conditions, but it does so in a different way than Tukey's HSD. Basically, it requires a bunch of additional F tests to be conducted. And in doing so, it evaluates the mean differences. So that's really a downside, is it's very, very laborious to actually hand calculate a Scheffé. So we're not doing any calculations using Tukey's HSD or Scheffé in class because they're just cumbersome, and they're things that can be accomplished with your JAS software. So we don't do that. But we need to know what these tests are and what they can do for us. So let's look at some different examples and put it all together. Let's say we had results of an ANOVA that had an F of 3 and 55 degrees of freedom equals 6.21. I want you to pull out your F distribution table. You can pause the video if you haven't done that. Look at alpha 0.05 and determine three things. I want you to make a decision about statistical significance. I want you to decide if we're going to conduct a post hoc test. And if there were unequal numbers in each group, which post hoc test could be used? So pause the video if you need to think about this. Okay, in this case, according to your F table, you would reject the null hypothesis, which means yes, you would conduct post hoc tests. And because there were unequal groups, unequal group sizes, you would use the Scheffé post hoc test. Okay, let's try another one. The results of an ANOVA revealed an F with 2 and 42 degrees of freedom of 4.44. Use your F table and an alpha at 0.05 to determine the same kind of things, decision on statistical significance, whether or not you're going to conduct a post hoc test, and if there were n 15 in each group, which post hoc tests could you use? Pause the video to figure this out. Okay, again, in this case, according to your F table, we would reject the null hypothesis, which means yes, we conduct post hoc tests, and we can use Tukey's HSD because the sample sizes are equal. You could do Scheffé if you wanted to, because it is a very conservative and test and really reduces the chance of type 1 error, but Tukey's works just perfectly fine in this case. Okay, one more. Results of an ANOVA revealed F with 2 and 27 degrees of freedom equals 3.02. Use your F distribution table and alpha 0.05 to determine a decision on statistical significance, the decision to conduct a post hoc test, and in this case, let's assume that there's unequal n in each condition. All right, take a moment to think about this. In this case, we fail to reject the null hypothesis. There was not statistical significance, and in that case, we don't conduct any post hoc tests. All right, that's all that's fit to print when it comes to ANOVA.